After UPG&A, we have kMeans right here. Okay, it is a code which is on the GitHub. You can open my GitHub by using your Colab. kMeans is another way to help us to analyze unsupervised data. We like to do clustering, depend on the distance. But unlike UPG&A, unlike hierarchical clustering, it has different approaches. So let's take a look at this code. I randomly generate this data point, okay, in a 2D surface, which is marked as the black circle right here. Okay, I have 3 central E, and I randomly generate data point around this central E with different variance. 就是我先随机选3个中心点，然后在这三个中心点的周围随机的生成一些点，然后给予不同的 variance 所以它会在那中心点附近有大有小会有一些这些数值。So for such kind of data point, if I don't know this data point is generated from 3 central E's with several different variances, if I simply just take a look at this data point, and I would like to cluster those data points. How can I do? So here is how kMeans does. At the first place, the people who try to analyze data have to decide a number. This number means how many clusters you would like to kMeans to help you to cluster those data. At the first place, you may say, okay, I would like to cluster those data into 5 different partitions. And how did you design these 5? We will teach you later. But at the first place, you have to tell the algorithm how many partitions you would like to apply on these data points. So for this example, I simply select a random number 7. So I would like to use the kMeans to help me to cluster all those data points into 7 different partitions. And the first step is to randomly plot 7 different data points on the original space. 好，所以它的第一步是，这样我要分7个区域嘛，对不对？我就随便的在里面找7个点，真的是随便哦，完全随机的 ，OK。And I mark them as in red. Okay, that's the first step. We have several group points. I randomly select 7 of them and mark them as in red. The second step is that since we know how to calculate distance, so that among all the other bullet points, I calculate the distance between each bullet point to all the other red points. 好，中文再讲一遍哈。我有了7个红色点跟其他所有剩下蓝色点之后呢，我要算什么？我要算每一个蓝色的点到这7个红色点的距离，这很简单嘛。And of course, select the smallest one. For example, I have a target point right here. So I calculate the distance between this blue point to all red points, right? And select the smallest one, which is this one, should be the smallest one, the colorless red point. And I mark this blue point by using this red point. Okay, since we have 7 different red point, okay, so I select 7 different colors right here. The yellow one. I have 7 different colors, so I have 7 different partitions right here. This red point has the smallest distance among these yellow points. 好，就是说呢，我们对每一个蓝色点去计算最小的红色的距离嘛。那一定会有最小的嘛，那我们就选定那一个。那我们对那个点呢，就是随机给个颜色吧。好，那比如说以左下角这边我们选了黄色。好，那我们就把所有跟这一个点恰好是最近距离的那些人呢，全部都标上黄色。好，所以左下角现在就会自成一区。这一区的人里面是什么呢？这一区黄色的点点的 data point， 它们距离这个中心的这个红色啊，我们刚刚随机选的那个红色点是有最小距离的，好吗？它们跟其他的点的距离都没有这个红色的小，所以它们就会被暂时在这一轮就会被标记成这个黄色，比如说黄色啊，以这个例子来说就是黄色。And of course, we do all the same things to all these 7 regions. So it means at the right bottom part, right here, all those light green points has smallest distance to this specific red point. So we mark them all in green. The color is just a random color, okay? For example, it's just a green color. So by doing so, we can simply just partition the original blue point by using a 7 random red points. Okay, that's the first round. What about the second round? We simply just remove central E in each partition. And then, in this partition, for example, the light green one partition, for all those light green data point, we select a new central E. The new central E has a specific feature, which is it should be the center of all these data points. How do we find this point? It's quite easy. For example, that is x1, that is x2. How do we find this blue point? For all these light green points, we simply just average their x1 and x2. We can find the new data point, which will be the new central E of this light green partition. 好，下一个步骤是说，那我们在这个，我们用那个红色的点找到了一群青绿色的点之后，我们就不管那个红色的点了。我们在所有的青绿色点中找一个新的 central E， 就是中心点。这中心点怎么找呢？看啊，这是个2维的平面嘛，对不对？是不是有 x 跟 x1 跟 x2？ 就把这些青绿色点所有的 x1 加起来做平均，就会得到 x1 的就是得到 x1 轴上的中心点嘛。然后把青绿色点所有的 x2 加起来做平均，你就会找到一个青绿色的 x2 的那一轴的中心点，就这样。没有什么特别的，就是找新的 central E。For the second round, we find a new central E of the light green section, green section, a dark green section, dark purple section, and yellow section. At the second round, you just ignore all the red points. We only look at the color points. For each section, for each partition, we calculate the new central E for each partition. So we have 7 new central E. Those central E might be or might not be the same as the red point, which is okay. But now, at the second round, we find a new central E. So we can see that is the second round. The new central E also marked as red, the new red, okay, the new red data point. Those central E is more makes sense because they truly at the center of each partition. 这个新得到的是 central E， 我们还是把它 mark 成红色的哈，然后我们就把它画在图上。这个新的 central 会比较 make sense 一点，因为它们真的就是那个颜色的中心点。大家要知道哈，在上面那个啊，我们那个不一定会在颜色的中心，它只是很靠近，就是那些颜色只是很靠近原本的红点而已。可是在下面这个新的红点呢，它们是真正这个有颜色这一群人的中心点。这样我们就完成了第2 round。Okay, that is the end of the second round. We have new central E, which is more makes sense. They are not randomly selected by some random number. Okay, and what next? If you download my code and run it in your Jupyter notebook, it is an animation. After that, for the third round, we use the new central E to mark the closest node. 就是在下一个阶段呢，我们会用这个新的 Ctrl E 再重复动作。那重复什么动作呢？去重新的再标记一次颜色。As you can see that when we find a new Ctrl E such as right here, for example, that is a new Ctrl E, right? That is a new Ctrl E. And take a look at this pink point. This pink point was the member of the light green partition, right? But after we have a new Ctrl E right here and here, the next run, this pink point will belong to the left Ctrl E because it is more close to the left hand side. So we will use the new Ctrl E to do new partition again. 好吗？你可以看到这上面，因为我们现在移动的 Ctrl E 嘛，对不对？所以大家的相对距离其实就稍微换了一下。所以某一些在边界的点啊，原本是属于旧的某一个 Ctrl E 的，可能因为新的 Ctrl E 现在比较靠近它了，所以它就会在下一轮被划到新的 Ctrl E 的那一边去。And so on and so forth. So the execution step is like that. In the first round, it is very different. Okay? We randomly select some Ctrl E. And then we partition the rest of the data point by using the random select Ctrl E. And then in each partition, we select a new Ctrl E. And then we have new Ctrl E, right? We do the new partition. And then we find the new Ctrl E. And then we do the new partition. New Ctrl E, new partition, new Ctrl E, new partition, and so on and so forth. And after a few rounds, we believe the Ctrl E will not change much. Will be stable somewhere in this space. Okay? So and then all the blue points will be partitioned. 在最后啊，我们就是不断的重复这个动作嘛，哈，选一个 Ctrl E， 然后把剩下点做 partition。partition 完之后呢，不要管 Ctrl E 了，在 partition 之内找一个真正的中心点，当做新的 Ctrl E。然后再不要管 partition 了，在新的 Ctrl E 里面再做一次 partition。然后在 partition 之后呢，就不要管 Ctrl E 了，再找一个新的 Ctrl E。然后找到新的 Ctrl E 是不要管 partition 了，我们再做一次新的 partition。周而复始之后呢，其实这个 Ctrl E 最后会稳定下来，我们相信它会稳定下来，然后呢你就可以停了。然后在最后的那一轮的最后的那个 Ctrl E 啊，还有那个最后的那个 partition， 就是所谓的 cluster。At the last run, the last Ctrl E and the last partition is exactly the cluster you are looking for. We are looking for. For example, if we have an iris data set, okay, we partition it into 3 clusters by using kMeans. Okay, this average is called kMeans, and we'll partition like this. But the next question is, we should provide how many clusters we should cluster, right? But when you take a look at this data set, if it has no colors, usually human beings will say, okay, I partition it into 2 clusters, not 3, not 4, 2, because obviously it can be partitioned into 2 data sets. But however, for some data set like this, how many partitions you should choose? 2, 3, 4, 5, 6, 7, 8. Basically, you don't know. Called elbow. Elbow 就是手肘的意思 elbow plot 就是手肘的这个图。What does that mean? That means I don't know how many clusters I should partition. So basically, if I have a data set, then I ask kMeans to do 1 partition, 2 partition, 3, 4, 5, 6, 7, 8, 9, 10 until whatever you want. So we simply just brute force, 就是我们暴力的去让它分1群、2群、3群、4群、5群、6群，就是随便到几群你想要的。就是因为我们不知道要分几群嘛 ，because we don't know how many partitions we should partition this data set, so we just ask the kMeans to partition it into 1 cluster, 2 cluster, 3, 4, 5, 6, 7, 8 cluster. we have a very interesting things. What is similar means? It means has less variance or less standard deviation. 就是我们在做这个 cluster 的时候，有一个很基本的概念，就是我们为什么会认为它是一群，是因为它们都缩在一起嘛，对不对？所以在群内要记住，我们现在用的词汇叫做群内，叫 within cluster， 就在 in cluster 哈。它们这样相似，所以它们应该要挤在一起。它们挤在一起的时候，表示它们的标准差很小，在那个空间里面，对吧？ So that is rule number 1. The data within a class should be similar, which means they are crowded. 它们就是很拥挤。Okay, they has less variance or less standard deviation. Okay. Rule number 2. Data between class. Between 的话，中文我们可以翻译成群间哈，就是每一群之间哈 ，should not be similar. The data between the clusters, they should be far away. So they should not be similar. They are not crowded. So they should be have high standard deviation. 就是群间的东西啊，因为它们看起来一群一群嘛，它们中间一定有空隙嘛，对不对？所以它们看起来比较遥远一点。那看起来比较遥远一点，表示这一群跟那一群的 standard deviation 比较大一点，就是它们的标准差要大一点。啊，如果它们在比如说你放在一个2维平面的话，就是 x 轴跟 y 轴嘛，它们 x 轴的 standard deviation、y 轴的 standard deviation 要大，所以群内要看起来挤嘛，群间要看起来散，这样才叫做一群一群嘛，对不对？这个是一个很简单的概念，就是人的认知嘛。So take a look at this view graph. What does it say? Average within the cluster sum of square.Average 就平均嘛 ，within cluster 就是指上面这个 ，this one，OK？、Sum of square 标准差怎么算？标准差不就是减掉平均值，然后平方和的什么鬼的之类嘛，对不对？所以左边的这个意思呢，它其实就是代表的是标准差的意思。So we have index which is standard deviation to help us to say, okay, I have a data set.If I cluster them using kMeans into one cluster, or 2 clusters, or 3 clusters, or 4, 5, 6, 7, 8, the standard deviation should decrease when there are more and more clusters, right? 对吗？你看嘛，你假设有一团资料，然后你就分一群。那个群一定里面松松散散的嘛，对不对？当你的群越分越小的时候，你会发现啊，它们之间呢，好像群的效果看起来越来越跑出来，对不对？那平均而言，标准差也会变小。好啊，这个稍微用想象的，好不好？这个很难画出来，用想象的。但是你要知道，你有100笔资料，你可以硬把它分成100群。那你把它硬分成100群之后呢，就是每个点之间的平均的距离哦，其实也蛮，就是理论上来说会蛮小的，对。所以实际上它是一个向下的曲线，会越来越小，会越来越小。但是我们通常会我们为什么把这个叫做 elbow 呢？就是因为下面这个曲线的图长得像那个手肘嘛，是有个弯折的点嘛，哈。那我们通常会怎么选择说到底要分3群还是4群？我们通常会在你觉得有转折的那个地方，就觉得说啊。有转折的地方表示说前面的群看起来都分得不好，到了这个点之后开始急转直下，变成说，好像看起来的确群的效果有出现，那只是越后面分呢，群的效果就看起来没有分得这么好了。比如说像下面嘛，像下面就是分2群看起来不错嘛，啊3群看起来也还好，可是你要硬把它分成4群的话，效果好像就没这么好了，对不对？但是实际上那个标准差还是会下降的，那个距离还是会下降的，但是看起来效果没这么好，所以它就没有像前面 dramatic 的往下降这么多，就是那个标准差。 所以通常我们会选一个转折点地方来选择我们的 K 值。这个 K 值就是 kMeans 的 K， 就是群，我们要分几群。所以下面这个我们可能会分2群或3群。So take a look at this elbow plot. Okay, that means what is the distance between different clusters? If you cluster the data point into 2, partition 3 or 4 or 5, usually we select the turning point, which is right here. Like for example, that's 3. Of course, 4 is okay or 2 is okay. It depends on you. Okay, so basically we select the turning point, which is 3, which means K equals 3. Let's take a look at orange as well. Okay, if you would like to do kMeans, that you don't have to calculate all these partition things and century things. You simply just right here. That's kMeans, right? That's kMeans. So take a look at the input. The input is data. The input is not distance, right? It's right data. So simply just connect the data from here to here. So this widget will help you to calculate the partitions and the centroid. So double click it. Since it is kMeans, you have to set the value of K. But if you don't know how many clusters, you can see, you can simply just click it. Okay, it says from 2 to 8. 2 to 8 means, okay, I don't know how to set the K. So please, okay, K equals to 2, 3, 4, 6, 5, 7, 8. Okay, but in orange we don't have the elbow plot. Okay, it has another index, but the theory is the same. Okay, and then it's done. But how did you know which point is partitioned to which part? Okay, you can connect a table right here and simply click connect it right here, and it will say, okay, that is the white columns are original features, right? And the gray colors are the target. And here we have an additional 2 columns, okay? And here it is, the cluster. C2 means cluster number 2, C3 cluster number 3, C1 cluster number 1, something like that. 就是它会直接告诉你答案啊，因为它没有办法把那个过程跑给你看嘛。So of course we can plot all the things. For example, here's a visualize, right? We have scatter right here, and we connect the data to the scatter plot. Okay, we connect all the data to data right here, and we can double click it. And we can see that right here. Okay, we have 2 axes. Okay, petal width, sepal length. So we can cluster it this way. And the color right here, is the Y. Okay, the iris is right. Of course, you can select cluster right here. The cluster right here is C1, C2, C3 made by kMeans. So take a look at this view graph. Okay, the left bottom side, those data are originally labeled as blue color, which is Sentosa. The middle part, okay, is original label as Versi color. Right hand side is Virginia. That is the original data. Okay, and after we select the cluster right here, that is the cluster made by kMeans. The left hand side part is quite good, but the right hand side part, that is not as good as the label. So kMeans has its limit because it's only used the distance to partition the data. Okay, after that is the. For example, we can here's the color. Okay, we can use shape. Okay, as you can see, the color is the cluster, right? That is made by kMeans. The shape is the original label. Okay, come with the data. So as you can see that there are 3 different colors, right? And the data marked as X is Versi color. Okay, so X right here is Versi color. However, some of them are not in green. The green is class number 3. So some of the color right here at the right hand side
they are labeled as triangle, which should be virginity. 啊，你反正这个工具很好用嘛，你就可以根据颜色或者 shape 来调嘛，就可以看到其实它们有不一致的地方。就是按理来说，最棒应该就是像左下角这样，红的全部是圈，绿的应该全部要是叉。可是你看到绿的有些不是叉，因为在 kMeans 的角度里面，他觉得这个跟这个比较近，所以它应该要是三角形。可是实际上在 label 里面，这个是这个 label， 表示 kMeans 在这个工作上没有做得很好，啊，没有做得很好。Okay, let's two different unsupervised learning. One is kMeans, the other is hierarchical clustering.